Hello everyone, in this video we'll be solving problem 3477 fruits into basket part 2. The problem statement is we are given two arrays of integer fruits and basket each of length n. We need to place the fruits according to the following rules into each of the baskets. Return the number of fruit types that remained unplaced after all possible allocations are made. And the rules are each fruit type must be placed in the leftmost available basket with the capacity greater than or equal to the quantity of the fruit type, and the basket can hold only one type of fruit. So we cannot place multiple fruit types into a single basket, and if the fruit type cannot be placed in any basket, it remains unplaced. Looking at example number 1, where the fruits given are with quantity 4, 2 and 5, while the basket size is 3, 5 and 4. If we start placing the fruits into the basket from the left side, the fruit with quantity 4 will go inside the basket with the size 5, 2 will go in the basket with size 3, and for the last fruit with quantity 5, the only basket remaining is with the size 4. As fruit quantity is greater than the basket size, it cannot be placed, hence we return 1. Similarly, in example number 2, the fruit quantity given to us is 361, while the baskets are 647. If we do the same math, all of these fruits can be placed inside this basket and there are no fruits unplaced, hence the output is 0. I hope you were able to understand the problem statement. Let's switch to whiteboard and discuss how we can solve this problem using the rules given to us. The simplest solution to solve this problem is using two pointers, where one pointer will be pointing at the fruits and the other will be pointing at the basket which are available. We'll start nested iterations on fruits and the baskets, and for each fruit we will check if the basket size is greater than or equal. If it is, then we'll mark that basket as unavailable and place that fruit. If not, then we'll continue the iteration on the basket until we find a basket that fits that criteria. At the end, if there are any baskets available which were unused, we'll return that value. Let's use this logic to solve this problem. We'll use this variable to maintain the number of fruits that we were not able to place, and use I pointer to point at fruits and j pointer to point at the baskets. Starting off the iteration with I is equal to 0 and j is equal to 0, and the remaining will be 0. The fruit quantity is 3 and the bag size is 6. As 3 is smaller than 6, we'll place the fruit into that basket and make it unavailable. As we have placed the current fruit in the basket, we don't need to iterate through the remaining baskets in the array, so we can break out of the loop, increment our I and restart the entire thing again. One way to know if the current basket is available or not is by maintaining a separate collection. But another way is to do an in-place operation where we'll change its current value to -1, so that during the iteration, if the j is pointing at a basket whose value is -1, we'll consider that basket as unavailable and move on with the remaining baskets. We have made all of the updates so that we can start the next run where I will be 1 and j will be 0. We'll check if the basket at jth position is available. As the value is -1, which means it is unavailable, so we'll increment j to 1. I is pointing at 6, j is pointing at 4. As 6 is greater than 4, we cannot place it, so we'll increment our j pointer. Now j is 2, I remains as 1. Fruit quantity is still 6 and the basket size is 7. As fruit quantity is less than the basket size, we'll place it there and mark it unavailable. Incrementing the pointers for the next run, I will be 2, j will be 0. As the basket at 0th position is not available, we'll increment j to 1. With I is equal to 2 and j is equal to 1, the fruit quantity is 1 and the basket size is 4. As 1 is less, we can place it over there and mark that as unavailable. As we are done with the iteration, whatever is the value saved in this remaining variable will be returned. As we did not encounter any fruits that could not be placed, the output will be 0. With this solution, our time complexity is O of n square, as we are running multiple iterations on fruit and basket to check if the fruit quantity matches the basket size. And the space complexity is O of 1, as we are doing in-place operations to update the basket size during the iteration itself. and only using this remaining variable to keep track of any fruits that could not be placed. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by initializing the remaining variable that will be returned at the end. I then start a for loop with the pointer pointing at the fruits array while another pointer j pointing at the array baskets. I am then checking if the value at j is not equal to -1 and the quantity of fruit at I is it less than or equal to the size of the basket at j. If both of the conditions are true, I am saving -1 in the jth position in basket array and breaking out of the loop. After the inner for loop is complete and the placed boolean is false, it means we were not able to place the fruits in any basket, so I am incrementing the remaining variable. This for loop will run for all of the fruits in the fruits array. Once the loop is complete, I am returning the remaining variable. This code, when submitted on LeetCode, beats nearly 57% of the submissions made so far in terms of runtime and 96% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.